only do you need a straight edge to do all of unit L, I shouldn't say all of unit L, but the first part of unit L, okay? But you need to be accurate with unit L, okay? Meaning, if you put on your graph, if you graph your points like that, and you want to put them in a line, but you take your straight edge and you go like that with your line, nowhere near your points, you are going to get the wrong answer. Okay? All right? So you need to be accurate with when you not only put your line on the graph, but how you go about doing that. And you need to make sure that you are covering up all of the points that you have plotted and making it accurate. But it's still covered up, isn't it? Okay? All right? So make sure that you are being accurate. When we told you back in the graphing unit that we had, what was that? J? I think J was graphing unit. Okay? Okay? H or J, I think we've been graphing for a while. When we told you that you needed to be accurate with that, we were telling you to be accurate for this day, today, and tomorrow, and Friday. Okay? That's why we were telling you to be so accurate. Okay? All right? So, if you would please do the 2 warm-up problems on L1. Go for it. How am I going to graph? We'll start with you, Keon. How am I going to graph letter A? Because that's the, what do we call that again? It is on the y-axis, yes, but it's the y-intercept. Yep, so this is the y-intercept. That's that plus b part of it. So that means we're going to go up to the point 0, 3. That's going to go up 1, 2, and 3. We're going to put a dot right there. Latcha, what are we going to do next? Down 2 and right 1, y. What's negative 2? This part right here? What part is that? What part is that? There's a word for it. There's also a letter for it. It is not x, no. It is the slope, okay? And what is the slope in y equals mx plus b? What is the slope? Oh, that's what the slope is in this one. What is the slope? Not in this one. Jake, give it to me. No. No. What is the slope? What? No. Say loud. It's the rise over the run. Okay? It's the rise over the run. So that's why we go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. If I didn't want to go down 2 and right 1, Michelle, what would my other choice be? Up 2 and left 1, up 2 and left 1. Okay? Then we accurately connect our line. Making sure we cover up or go through all of those points, and we have our arrowheads on our line outside of the grid. Come on, don't let me twist it. Come on. Yep. With me on that one. use it. Okay? So what are we going to do first in the next one? Because they look different, right? A and B. Faculty, what are we going to do first? Nope. These two, but the problems look different, right? If I highlight the problems here, my man, here's the first problem right there. Here's the second problem right there. Those don't look the same, do they? Which one do you like better, left or right? The right one you like better? Well, you tell me which one. You give me both of them now. Why do you like the left one better? No. Chloe, why do you like the left one better than the right one? Because you can go straight to graphing it, right? You can go straight to plotting your y-intercept and using your eyes to run like what we just did, right? You see what I'm saying on that one? Okay, so back to you, Dylan, now. So now we got to make the right one look like the left one, right? So what do I have to do to the right one? It's one word. It could be two words, but that second word could also be a number and one letter. Okay, tell me what you want to do first. I don't know, yeah, exactly. What do you want to do first? Subtract 2x. Do you know what the one word slash number and the one letter is? Like the sentence that I'm looking for of what we're actually doing here. You were correct. The first thing we're going to do is subtract 2x. You know what that word, that little phrase is? No? Okay, we'll get to it. We'll see if we can figure it out as we go along. Okay? So, you said subtracting 2x from both sides. I like it. So then that's going to give me negative 3y equals negative 2x plus 6. Okay? Jake, did you figure out the word, the number, and the letter yet? Okay, so what's the next thing we're going to do? On all of them? Okay? What are you doing here when we divide by negative 3 on all of them? It's also a word, a number, and a letter. No, not yet? Okay. Wyatt, negative 3 divided by negative 3. That just gives me y, right? Yeah, I like that. Okay. Negative 2y divided by negative 3. It'd be positive, right?
Yeah.
Yeah, it would be 2/3. Heck yeah, it'd be 2/3 x, wouldn't it? Yeah. Lots of times we forget to put that x in there. Yeah. Okay. Positive 6 divided by negative 3. Negative 2. That's what we call a trifecta. You just did 3 of them right in a row. Boom, boom, and boom. Nailed it. Negative 2. Love it. Dom, talk to me. Have you figured out what the word, the letter, or excuse me, the word, the number, and the letter have been? For what we just got done doing. That's a lot more than a word, a letter, or a word, a number, and a letter. Will, you got it?
Solve for x.
Not for x. We didn't solve for x.
Oh,
We didn't solve for b. What did we solve for? Y. We solved for, get it? The word FOR could also be a number, the number 4. We solved for y. Okay? So if we haven't solved for y, we got to solve for y. Okay? Dom, back to you now. Talk to me. We want to graph y equals 2/3 x minus 2. Lay it on me. Talk. How do we do it? Down 2, because that's our b, right? Yeah, we remembered that way over here. And we got to go down 2 first. So we put a dot there. Okay, then what? Up 2 and right 3, because that's our slope right from here. Okay, so we're going to go up 2, right 3, up 2, Write 3. Love it. Jay, what if I didn't want to go up 2 and write 3? Yes, I do. Okay. And then we accurately draw in our line. Right? And there we go. Okay. Today, that is what we're doing. We're going to repeat that process again and again and again and again today. The only difference is instead of us doing 1 line per graph, we're going to be doing 2 lines per graph. We're going to do 2 lines per graph because we have something today called a system of equations. Okay? So a system of equations is a collection of lines involving the same set of, actually, excuse me, wait. Hold on, tap the brakes. I don't want to say it that way. I want to say the same set of a collection of equations, which is lines, we'll do equations and then we'll do involving the same set of variables or points. This right here is an example of a system of equations. We've got multiple equations involving the same 2 variables, okay? Which means then we have the same points on that line. Okay? What our job today and going forward with this unit is we need to find the solution to this system of equations. And a system with 2 variables, because we'll always have, well, I shouldn't say we'll always have 2 variables, we could have horizontal and vertical lines. A system with 2 variables will have a solution which is an ordered pair, whoa, tap the brakes, which is an ordered pair remember that is a point x comma y. So that's a point. And it's going to have a solution that's a point that makes this is the key word right here. Both not just one, it makes both equations in the system true. Okay? It makes both of the equations true. Not just one of the equations, both of the equations. And in the end, we're going to determine, or we're going to check our work by doing what we're going to do here in numbers 1 and 2. We're going to say here that that ordered pair, that point right there, is going to be, we need to figure out if it is a solution to our system. Well, if it is a solution, then the x value and the y value, when we plug it into our equations, plural, because we got to plug it into both equations, okay? When we plug it into both equations, we get a true answer. So how we would go about doing this is, we would take 2 times x, but now instead x is going to be 3. Write this down, because this is how we show our algebra. Then we're going to say minus 3 times y, but y now is negative 4. And that has to equal 18. If it doesn't equal 18, it is not a solution. Okay? If it does equal 18, then it is a solution. You tell me the left side doesn't equal 18. Because 2 times 3 right here, that's 6. Negative 3 times negative 4 is positive 12. 6 plus 12 is 18. And 18 is equal to 18. So it works in this first equation. So now we have to go and check it in the second equation. So now we got to go 8, and you can't get around this. Just because it works in one equation doesn't mean it's a solution to the whole thing. Okay? It's got to work in both equations in order for it to be a solution. 8 times 3 minus 2 times negative 4, and that's got to be positive 32. 8 times 3, anybody? 24? Negative 2 times negative 4. Negative 2 times negative 4. Positive 8. Negative times a negative is a positive. 24 plus 8. 32. Is 32 equal to 32? Yeah. So it worked in both of them, yes? So therefore it is a solution. Or you could put yes there. It is a solution. Or you could put solution. Yeah. Let's try it in the next one. We'll try it. So if we go negative 9 times 3 minus 4 times negative 4, that's got to equal negative 11. Negative 9 times 3. Coro, I think we're up to you. Negative 27. Negative 4 times negative 4. Coro, we'll stick with you because you got a calculator out and see the price of that. I'm not that. Wait, she literally has one out, so I don't need to sit here and do think about it. I don't know. Okay. 16, so positive 16. Negative 27 plus 16. Negative 11? Yeah, negative 11. Yeah, it worked out. Okay, so it checks out there. Gave you the smaller numbers. Right? 3 times 3. 4 times negative 4. 4 times negative 4. Negative 16. 9 minus 16. 9 minus 2 is 7. I said 9 minus 16. You gave me 9 minus 2. I know. I get it. I get it. I get it. I mean, they're pretty far away. 9 minus 16. Should be negative 7. Right? Verify it for me. You said positive 7, which is different than negative 7, right? 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 Okay, yep. So negative 7. Is negative 7 equal to negative 7? Solution, not a solution. Solution. Yep, we got a solution again here. All right, let's get into it now. Okay? So what our job today is we're going to graph these systems of equations and we're going to find that solution point. Okay? So I'm actually going to skip to number 6 first because that's what our end product is going to look like in number 6. You're going to have 2 lines drawn on your graph, and those 2 lines hopefully intersect somewhere. What happens if those 2 lines don't intersect? Then it's not a solution. There's no solution if they don't intersect. We are looking, Yasser, for that intersection point right there. That's what we're looking for when we're trying to find a solution to a system of equations. Okay? What are the coordinates, Yasser, of that intersection point in number 6? X comma y. Yep, I want my point, remember, because points are x comma y.
So, points y.
Yep.
And
so what is that circled point?
x.
Would be, I need numbers here now.
Oh, numbers.
Yes.
-2.
Minus 2, comma, positive 1, right? Yep, exactly. So our solution set here would be the point -2, comma 1. Okay? Because that's that point where those 2 lines cross. Everybody with me on that? We're looking for that point where those lines cross. Okay? Now, let's jump back to, actually, we can save number 5. We don't have to, we can not, that way we don't have to jump back. We'll stay with number 5. We have to graph both of those lines on the same graph. Okay? So let's deal with the first one first. Okay? So this one right here. What is the y-intercept of that one?
Negative or positive 3.
So that means I go
Up 3.
up 3 from the origin. 1, 2, and 3. What is the slope of that one?
2.
2. So that tells me what's my rise over my run.
1 or the 2 over 1.
So it rises, so give me 2 directions, 2 numbers.
Up 2, right 1.
Okay, if I don't want to go up 2 and right 1,
Down 2, left 1.
love it. And here's where that accuracy comes in. Now we need to draw in our line, and we need that line to go all the way across the graph, and we need to connect all of our points. Right? We need to be as accurate as we possibly can. Okay? So we're there. Love it. You ready? Second one. What do we got to do first? It's a word, it's a number, it's a letter. We guessed it earlier in our warm-up, in our second warm-up. Start with solve, a number, a letter. Y. We need to solve for y, right? Okay? Right? How do you want to go about solving this one for y? Well, we got to get y by itself, right? So how would you get y by itself in, here, let me put a green box around it. I want to solve that green one for y. Divide's always last. Gotta move stuff first. Add what? But the 2's got the x attached to it. So I can't just add the 2 and the 4. Okay. Michelle, what do you got? We want to solve for what? Subtract what? 2x from both sides? That then is going to give me negative y equals negative 2x plus 4. Watch it, did I solve for y yet? Why not? Because there's a negative yet, so what do I got to do? Divide everything by negative 1, right? Okay, so I divide everything by negative 1. So that gives me what, Pasha? Let's work left to right. Yeah, speak louder, people know it. -4. Okay, love it. Okay, Kiana, I want to graph the line y equals 2x minus 4. Down 4. Okay, and then what's my slope? Up 2 and right 1. 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 All the way up there, right? Or bingo. Down 2 and left 1. Down 2 and left 1. Down 2 and left 1. Love it. Ruh-roh. What happened there? Dylan, did they cross like in number 6? No. So that means I can't get a solution, right? Right. So then we would say, in this case, that there is no solution. No solution. Because they don't cross. Like in number 6. We're looking for spots where they cross. Okay? Let's try 3 or 4. Chloe, which one do you want to do? 3 or 4? 3? All right, let's do it. Let's do number 3. You want to do the blue line or the green line? You tell me. Blue? Up 1 gives me my y-intercept. Down 3 and right 1, right? Okay, that's my slope. 1, 2, and 3, right 1. 1, 2, and 3, right 1. Or I can go which my other 2 directions? Up and left, right? Yeah. Okay. Then we draw our line. And right there. Love it. Stephanie, you got green. Talk to me. Down 4. 1, 2, 3, and 4. Up 2 and right 1. 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 Up 2 and right 1, right? Or bingo. B-I-N-G-O, and bingo was his name. Oh. Drawing that line. Jake, did those lines cross? Yeah, they did. They made an intersection point, right? That's going to be our solution, correct? Okay? What are the coordinates? The x, comma, the y for that intersection point. 1, comma, negative 2. 1, comma, negative 2. Love it. Does everybody agree with it? Okay? Here is how you know. You do what we did down here on your solution. It's because it's gotta work in both of them. So I'm going to plug in 1, comma, negative 2 into my blue equation. So that's going to be negative 2 equals negative 3 times 1 plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. And negative 2 is equal to negative 2. So it works there. Then I'm going to do the same thing, but into my green equation. Negative 2 is going to equal 2 times 1. Oops, I forgot the minus part. Minus 4. 2 times 1 is 2. 2 minus 4 is negative 2. And oops, I put negative 3. Negative 2 is equal to negative 2. Checks out. We checked our answer, so now we have the right to say that yes, that is a solution to it. Okay? You now try number 4. Please do number 4. Everybody agree with me on that? On the blue one. Y-intercept is 4. Slope is negative 2, so I go up 4 from the origin and I put a dot. From that dot, then I go down 2 and right 1, 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 down 2 and right 1. Or I could go up 2 and left 1. Okay? Then, now we're going to go to our green line. I forgot where we left off. Where did we leave off? Jake, I think we left off at 2, didn't we? Yeah, I think so. What do we got to do to solve for y? Subtract x? Okay. So then that's going to be 3y equals negative x minus 3. Then what do I got to do?
Then you gotta divide.
Divide everything by 3? That is going to give me y equals negative 1/3 x minus 1, correct? Okay, so that means that gives me a y-intercept of negative 1. Do you agree, Wyatt? Okay, that gives me a slope of negative 1/3, which would be down 1, right 3. Would you agree with that?
Yeah.
Or I could go up 1 and left 3. Would you agree with that? Love it. You concur? That's good. Drawing our lines, we got that, correct? Down do they intersect? What are the coordinates of said intersection? So what are the coordinates? X, comma, y. Three comma negative 2. Then I said we should check that to make sure it works, right? Okay. So if I plug that back into my blue equation, I would get negative 2 equals negative 2 times 3 plus 4. Negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. And negative 2 is equal to negative 2. Checks out. Then I gotta plug it back into my green equation. X is 3 plus 3 times negative 2 has to equal negative 3. That gives me 3 minus 6. 3 minus 6 is negative 3. And negative 3 is equal to negative 3. So that is my answer. Okay? That is what we are going to be doing this evening on the homework. Okay? You only get better at this stuff the more you do it. You sit there and you don't do the homework and you put off the homework and you put off the homework, you won't do as well on all of the assessments. End the year strong.